semi-static rope, you can already see that it's stretching a lot. Some of the stretch is what we call construction stretch, the other one is material stretch. There will always be this, construction stretch and material stretch. We're losing already the balance as it tension itself. Some parts of the knot will constrict themselves over the rope more than others, and then suddenly you're already unbalancing your rope quite a lot. And this is part of the problematic, that you can't be certain that you will reach this the same result every time. It just depends on the way the knot was tied, depends on the way the load was imposed on the knot. And once again, I'm going back to the fact that, and the need to really calculate with 50% loss. Forget about the rest of the argument. It's worthless. What's happening right now, as I'm putting on it, I don't see anymore a drop on my load cell. What's happening is that I have now passed on a curve of study of stress. What you see is that there's a place where you're in really the elasticity, where after when you relax the load, the material regains its initial form. At this point, we've passed this. We're heading to a break right now, basically. And we're already creating damage on the fiber. Light damage on the fiber. É a carga de ruptura da corda. Nesse caso, a gente abaixa o nó, usa 50%. So what I was saying is that we did a test earlier before you guys came. Same rope, same knot, well made by us, and we ended up at 1,700 kilos. There's 500 kilos of difference between the two tests. The previous one made early this morning and the one we just made. Same rope, same knots. And this is the real biggest problematic of knot, is that you just simply don't know when they're gonna break. So once again, but of my experience, I've never seen a knot breaking below 50%. Use the worst case scenario, 50%, you're done. Okay? What's very interesting also to see, guys, it's at the release of energy, when it breaks, you have a release of energy and it melts the rope, actually. There's places where you can see that it's melted. E agora é sempre o que vai acontecer, a quebra está acontecendo no nó. Sempre. Ok? Acho muito claro o que está acontecendo na fibra.
So you can clearly see it's actually part of the knot that has actually been the cause of the break.
Always.
Yeah.
It's really reducing from 3,500, we're floating at 2,100. Okay, so just one more time, be extremely careful and consider this in your design factors. This is really the thing we need to remember. I'm going to talk a little bit about splicing. The goal of splicing is to create an interlocking system that respects the rope configuration and the engineering of the rope in order to work on, instead of strangulation, it's working on friction. It's that I'm bringing back the fiber over each other, I'm replacing them in a logical construction so that I respect the best I can the rope configuration defined by the manufacturer so that I can retain the most of the total breaking load. Okay, so here we have a sample of a rope that has been spliced. A well spliced rope should reach the 98% of the total, if not 100%. So I'm trying to explain to them that my feel is that we have a high potential of break at the eye because of the D to D ratio. We're not respecting the D to D ratio right now, and it's likely that it's not going to break on the length, but over there at the eye. Okay. So actually this could be a great thing to break. So what's happening is that the stretch you're seeing here is much more the fiber. It's the braid, the braid starting to take position with the vector of forces. So it's not an elongation of the fiber, but it's much more of a construction stretch that we're seeing right here. And you guys can see that we're reaching like a staticity so much faster. You can see it on the screen as we proceed towards the break. And you see that little movement rings out. Really drastic. So it broke at 3,000. So 1,000 kilos below. And let's see where it broke. Exactly where I said it would break, which is at the eye, which is not a splice failure, which is not really a rope per se failure. It's much more of an eye failure due to a problem with D to D ratio. We were having such a small eye into a big shackle pin. It's really bad. And what happened is that the fiber most than likely started breaking on the outside, started dropping the load towards the inside of the eye until you have this very fast chain reaction. You saw how it broke. Huh? Okay, and this is typical of a D to D ratio problem.